All right, so let's try another one along the same lines. We have the integral of 5x e to the 8x dx. I'm going to go ahead and drag that 5 out front, just so it's not in the way. And let's learn from our previous mistake that we do not forget the 1/6. Well, in this case, we're not going to forget the 5. Okay? So if I use u substitution, my u would be 8x, my du would be 8 dx. So this x is what's causing the problem, so I drift towards integration by parts. So I have a u and a dv, which will then give me my du and my v. So which one looks easier, the x or the e to the 8x dx? Okay, so e to the 8x dx looks harder, so it's going to be my dv. X looks easier, so it's going to be my u. Okay, so what's the derivative of u? It's 1 du. What's the derivative of x? It is 1 dx. What is the integral of e to the 8x? So remember, you'll need an 8, so balance with a 1/8. So I get 1/8 e to the 8x. And now I'm ready to dive in. So I've got x times 1/8 e to the 8x, u times v. So 1/8 x e to the 8x minus the integral of v du. So 1/8 is going to go out front, and then I've got an e to the 8x dx. Okay, so I just put my 1/8 out front as a constant multiple, and then I've got an e to the 8x dx. Well, this, I need an 8, so balance with a 1/8, which will give me a 64. Okay, so my answer is 1/8 x e to the 8x minus 1/64 e to the 8x. What did I just put? E to the 8x plus c. Remember, this 5 is coming along for the ride. So I'm going to have a 5/8 and a 5/64. Okay? So a 5/8 and a 5/64. Okay? So let's try another one. All right, I've got the integral of e to the x plus or minus 7x squared dx. So if I try just u substitution, my u would be what's on the inside. So my u would be e to the x minus 7x. I do not have anywhere close to having its derivative. Okay, so now I'm back to, good heavens, how do I solve this? So remember that this is an e to the x minus 7x times e to the x minus 7x. So I'm going to FOIL it out and combine like terms. So e to the x times e to the x, if your bases are the same and you're multiplying, you add your exponents. So x plus x is 2x. So I have the integral of e to the 2x. Now I've got a minus 7x e to the x minus 7x e to the x, which means I have a minus 14x e to the x. Then I have a plus 49x squared dx. So this I know how to integrate. This I know how to integrate. This I'm going to have to do integration by parts. Okay? So I think what we're going to do is, well, let's go ahead and integrate this part first. Okay, so I have an e to the 2x. Ignore everything else. My u would be a 2x, so my du would be 2 dx. So I need a 2 balanced with a 1/2. So this term will integrate and become 1/2 e to the 2x. Okay, this one is going to be plus 49x to the third over 3. So we have plus 49x to the third over 3, and we know we're going to end up with a plus c. So it's this middle part I've got to worry about. So I'm going to use him as a second integral. Okay, so I'm just going to rewrite down here just so I've got some space. So I'm going to put a negative 14 out front, and I've got an x e to the x dx. Okay, so on just this portion, I'm going to have to use integration by parts. So my u and my dv Well, my u is going to be the easier portion. So my u is x. So my du is dx. I went on the wrong line. Okay. My dv is what's left over. So e to the x dx. And the integral of e to the x is e to the x. So v e to the x. Okay, so this answer, remember that negative 14 is going to belong to everything in this portion. So I'm going to have a negative 14 times uv, which is x e to the x, minus the integral of v e to the x du dx. Okay, so this is just e to the x. So now I've got a negative 14 times x e to the x minus this integral times negative 14 turns it to a positive. Okay, 14 e to the x. So this portion right here, I'm just going to copy up into this spot up here. So I've got a negative 14x e to the x plus a 14 e to the x plus 49 x to the third over 3 plus c. Okay, so you just had to do integration by parts on that little middle part right there. All right, so let's try another one. We have something similar. All right, so I've got an e to the negative x plus 3x squared dx. So again, I cannot use just plain u substitution. So I'm going to have to FOIL this thing out. So e to the negative x times e to the negative x is going to be e to the negative 2x. Okay, e to the negative x times 3x gives me 3x e to the negative x, but I got two of them. So I've got 6x e to the negative x. And then I have 3x times 3x is 9x squared. So this is my FOILed out integrand. I can integrate this. I can integrate this. That's going to cause problems. So let's go ahead and get these two out of the way. So if I've got a negative 2x, that means I need a negative 2, so I balance with a negative 1/2. So e to the negative 2x. This one is going to be 9x to the third over 3, which will be plus 3x to the third. And I'll round it out with a plus c. So I've got to look at this part now. So I'm going to rewrite that with a 6 times the integral of x e to the negative x dx. Remember that 6 is going to belong to everything I do. And now I've got integration by parts. So u and du, dv and v. So what looks easier? So x, it looks easier, take its derivative. E to the negative x dx means I need a negative 1. So balance with a negative. So this is going to turn negative. Okay, so my answer, remembering my 6, is uv, so negative x e to the negative x, minus the integral. Okay, so minus a negative is going to turn positive. Minus the integral of e, or v du, sorry. So e to the negative x dx. And now once again, I'm in that situation where I need a negative, so balance with a negative. So this final thing, this term is going to get the 6. So negative 6x e to the negative x. This term is going to be just negative e to the negative x. E to the negative x. So the negative came back in because I needed to balance, and then I distributed the 6. So these two pieces are going to come back up in here. So I have a negative 6x e to the negative x minus 6 e to the negative x. Okay, so my final answer looks like that. Okay, this one. All right, so we got time for a couple of more in here, and then we'll have to go to a third video, sorry. All right, so I've got x plus 6 times e to the x dx. Okay, well, I'm going to go ahead and I could leave it like this, okay? And I could make my u the x plus 6. And then my du would just be dx. Okay, I think I'm going to do that. All right, or I could distribute and do x e to the x and do integration by parts there. And then 6 e to the x is just integrable the way it is. Let's just do it this way. It'll be fun. All right, so my u is going to be the x plus 6. And my dv is going to be the e to the x dx. Okay, so I've got this portion and I got this portion. So my derivatives will be 1 dx. My integral, I don't need to balance anything, so he's just e to the x. So now what I have is uv, so don't forget your parentheses. So uv is going to be x plus 6 e to the x minus the integral of v du. Okay, so do I know how to integrate this? I do, it's already done. So I have x plus 6 times e to the x minus e to the x plus c. Okay, minus e to the x plus c. And you're good to go. All right, so number 7. Let's look at that one. Hey, it's pretty much the same thing. All right, so I have the integral of x minus 3 times e to the 4x dx. So I immediately know I'm going to have to do some balancing here. Okay, so my u is going to be an x minus 3. My dv is going to be an e to the 4x dx. So what's your du? My du is 1 dx. My v, I need to balance. My u, if I was just doing this, okay, my u would be a 4, so I would need to balance with a 1/4. And then I would get e to the 4x. Okay, so my formula is uv, so 1/4 times x minus 3 e to the 4x minus the integral of e to the u, or sorry, e to the 4x dx. So 1/4 e to the 4x dx. So I'm going to have to balance this one again. My u is 4x. So I need a 4 balanced with a 1/4. So I'm going to multiply by 1/4. So now I've got 1/4 x minus 3 e to the 4x. This turns into a minus 1/16. And then the integral of e to the u is e to the u. So he's e to the 4x plus c. Okay, so he's done. All right, so let's try some that don't have e's. Actually, let's stop there and then I'll come back. Okay,